So when you go to Canvas, now this Zoom link is for your parents. I don't know if they're going to come by or not. They don't have to, but if you want them to, you know that next week, Wednesday, we have back to school night, okay? So if they have any questions, back to school night, we do have a schedule. Tell them to just click on this, okay? And I'll be more than happy to kind of answer their questions, help them, and guide them through the Canvas and all that stuff, okay? Now, for class resources, right here, you go ahead and click on the class resources. And I think I already told you this. All right, so we go to CalChat, which is your solutions. And we go to calculus on the very left, and then you press arrow till you find your textbook, which is this one. And you click on your textbook. And let's say we're working on chapter 2 and section 1 today. And let's say you are stuck with number 21. And then you go, and it shows you how to find the solutions like that. Now, I don't want you to just start copying down the answers. I think the whole purpose of us being here again is to learn how to solve these questions, right? So you do that. If you get stuck, look at it, see if it helps you or not. But sometimes your answer, if you look at some of the questions, let's everyone open up to page, take out your book, and open up to page 131. 131. Are you on page 131? Okay, very good. Now, some of the numbers are in red. Can you tell me which numbers are in red?
7.
Which one? Number 7. Okay, 13. 27. Okay, so let's say if you're working on those questions, what you do is you go to Calc View, which is underneath. Do you see that? You click on that one. You go to Calc View, and then this is our textbook. We go to chapter 2, and then section 1, exercise number 7, and you click on the video, and someone will help you with that problem.
The definition. Find the slope of the graph of a function.
Okay, so you get the point, right? So we're good? All right, so you can tell that we have really good resource on your Canvas. Do you see that? You have all the solutions to the odd ones. And then you have some videos you can watch if you need some help. And remember I said all of your exam questions will come from where? From your book. And it could be odd or even. All right, does that make sense? So if you want to practice, you can practice on those even questions that are similar to your homework problems. Does that make sense? All right, so that's very good. Okay, all right, go ahead and grab a textbook. It's on the left side. Okay, do you see the bookshelf?
That one?
Yeah, go all the way to the left and then pick up a calculus book. All right, so here we go. So I'm going to go over about 4 examples with you guys today. So everyone turn to page. Sorry, not the page I want you to see. All right. All right, so open up to page 124. 124. Page 124. Here we go. All right, so we're going to look at tangent line and derivative. All right, this is the title of your chapter 2, section 1. All right, so we study limits in chapter 1. Now, we need to use those limits to find other things, right? I mean, we study limits for what, right? Just because I want you to study limits. There's a reason why we study limits. You understand that? So let me give you an example. We're going to start with tangent line. I don't even know if you guys understand what tangent line is. Anybody know what tangent line is? Anybody? Okay, so let's go back and review. Let's say, here's an example. This is a review, supposedly. But if you don't know it, I guess it's not a review. Okay, here's a function. It could be any function. We can look at any type of function in this class, okay? We're going to look at a lot of difficult and challenging functions in this class. All right. So we have a whole bunch of like little points on here that goes along the curve. You understand that? We have a whole bunch of order pairs that goes around the curve like this. And anywhere along the curve, let's say right here, do you see this point? If I draw a line that is barely touching at that corner, we call this to be a tangent line. That will be your tangent line. So with limit, in calculus, now we have a way to find all of these tangent lines, anywhere you want. It is possible to find all of these tangent lines, right here. Alright, so we're going to find, our goal is to find, not all of them, but wherever they ask us to find the tangent line, we need to find that tangent line. Okay, now this is all review. How do I find the equation of a line? What do we need to have in order to find the equation of a line? We need to have, you need to have a slope, which is rise over run. You need to have a slope. What else do you need to have? You need to have a point. It could be a y-intercept, but you need to have a point, x1, y1. And we also need to use, we can use any type of linear equation, but I want you to use for this class point slope form. Do you guys remember your point slope form? Y minus y1 is equal to m times x minus x1. I want you to use that. All right, these are all review. We haven't even covered calculus yet. You understand that? Those are some of the stuff that you need to know and use in this, lesson. Are we clear? All right. So our goal is to find these things. But to find the slope, I'm going to put a star on this. To find the slope, we need to use calculus. That's the hard part. Okay? So do you see this slope right here? To find this one, the order pairs are easy. The points are given to you. To find the slope, we need to use calculus. What do I mean by calculus? We need to use limits. Okay? So now we're going to go into our lesson. Our lesson says derivative. But derivative is a fancy name, okay? Derivative is a fancy name for tangent slope, which is m. Derivative is a fancy name for tangent slope. So, on page 125, go to your page, at the bottom, we have a definition of a tangent line with your book, it says the formula for m, which is your slope, is equal to limit change of x goes to 0, f of x plus change of x minus f of c all over change in x. All right. Now again, your book is trying to be fancy. This change of x, which is triangle x, sometimes in other science class they call it delta x. Did you know that delta means change?
Yeah.
Okay? So they're trying to use fancy notation. But it could be any variable. I could have used, sometimes they use limit h goes to 0, f of x plus h minus f of c all over h. Same thing. I can use any variables. Does that make sense? It doesn't have to be change of x. Or I could have used x. But I don't want to use x because what happens if I just use x? Why can't I use x? Can someone tell me? You know, you get the same x's. I don't know which x is what x. Does that make sense? You need to have a different variable. I could have used c, but can someone tell me why I cannot use c? Because you have the same matching variable. So I don't know. So that's why you need to use some other variable. So either you can use this fancy variable, which is change of x, or you can use letter h. It doesn't really matter to me. Pick one. I'd rather have you guys use this, okay? Alright, so let me show you how to use this. This will give us the tangent slope formula. So we can use this formula to find any slope anywhere along the curve. Anywhere. So for that example, we're going to turn to example 1. No, I lied. We're going to turn to example 2 on page 126. This is page 126, example 2. Alright, this one says you have f of x function, x squared plus 1, and we want to find the tangent line. At two places. Part A, at point 0, 1. Part B, at a point -1, 2. So I'll give you time to copy this. Alright, you don't need to graph this, but I want you to understand what's going on. It's always good to kind of visualize what you want to do. I think most of us understand how to graph this. Do you guys know how to graph x squared plus 1? Can you visualize it in your head? Yeah? So isn't it just a parabola?
Yeah.
Isn't it a parabola that starts at 1 and then it opens up like this?
Yes.
So along this curve, do you see this curve? We have a whole bunch of points. But we're not going to use a whole bunch of points. We're going to pick some points. Which points are we using?
0, 1.
So we're going to use this first point. Can you visualize a tangent line at that point?
Yeah.
Doesn't it go somewhere like this? So we need to find the equation of this line. Do you see it? That's the first part. They're asking you to find the equation of this red line at that location. Does that make sense? All right, we have a second point. Where's our second point?
-1.
Isn't it someplace over here someplace?
Yeah.
All right? -1, 2, close enough. My graph isn't all that great. And what do they want you to do for the second part? Can you visualize your tangent line at that point?
Yeah.
Kind of looks like this, doesn't it? And they want you to find the equation of this line. So we need to find two equations. But do you think it's possible to find all the points along this curve if you wanted to?
Yeah.
But hold on a second, okay? Hold on, let me pause this. Oh no, we're good. I think we're good. Okay. All right, so we're gonna continue. All right, so to find this thing, remember I told you that we need to find the slope of each one. So we're gonna start with this line first. So this is part A. All right, part A. To find the slope, which is m, to find the slope, we need to use a formula. What formula did I ask you to use? I boxed it. Limit h goes to 0, f of x plus h minus f of c all over h. Are we good?
Yes.
Okay. Now, when you use this, do you see this f of c? Remember before it was, let's go back and review. We said it was limit x is approaching to c. Remember that? Like we label it that way. X is approaching to c. So this c is actually describing your x as well. So you can convert that into x. You're supposed to just know that, okay? So I'm just telling you to switch f of c as x. Alright, so I don't know if you guys remember this from integrated 3. I need you to find this thing. What is f of x plus h? Anybody have an idea what f of x plus h is equal to when you have function of x squared plus 1? Anybody have an idea? Think about it. I'll give you about 30 seconds. Alright, so pay attention to me. So I'm going to use this as a bracket right here, okay? I'm just going to find this one first. I'm going to use a bracket. Just don't write anything. Just pay attention to me, okay? To find f of x plus h with this part, you think of x as a parentheses. So this is parentheses, x plus h, close the parentheses, square plus 1. Okay, how many of you guys follow what I just did? Well, I'm just substituting. Do you see this parentheses? I'm substituting this whole parentheses into x, and you think of x to be parentheses. I'm just replacing it. All right? All right, so go ahead and copy that. Okay, minus. Okay, pay attention to me. Do you see the second part, f of x? F of x is easy. I'm going to use a bracket, second bracket for the second part. So minus bracket. What is f of x?
X squared.
Yeah, it's just x squared plus 1. Okay, how many of you guys follow what I just said? Raise your hand. It's just that, isn't it? F of x is f of x, x squared plus 1. All over h. Alright, so I'll give you time to copy that. 10 seconds. Alright, think about this. Can I use direct substitution? No. Why not?
Because your denominator is 0.
0 as a denominator. So what do we do if you have a 0 as a denominator? What do? We need to use some other method, right? So we need to simplify this. We need to simplify the top. Can we FOIL this? Can you help me to FOIL x plus h squared? Isn't that x plus h times x plus h? Remember I told you in calculus class you should be able to FOIL that in your head?
Yeah.
Alright, so let's see. So go ahead and FOIL that.
X squared.
So I'm going to use a bracket. What is it if you FOIL x plus h times x plus h?
X squared.
X squared plus 2xh plus
H squared.
h squared plus 1 and close a bracket minus bracket x squared plus 1 all over h. Alright, I'll give you time to copy that. Okay, now I can distribute this negative. Do you see this negative? When you distribute, you take out all the brackets. So go ahead and take out all the brackets and distribute. So this is limit. Stay with me. Don't copy yet. I take out all the brackets. So this is x squared plus 2xh plus h squared plus 1 minus x squared plus, oh, it's not plus, is it, huh?
No.
Minus 1 all over h. Alright, so go ahead and copy that. This is minus. I want you to stay with me. You can copy this later. I want you to follow my steps, and I'll give you time to copy. Alright, so once you copy this, is there anything that we can cancel, like terms? Is there anything that we can combine? X squared and x squared, and negative 1 and positive 1. And what do you have left over when you cancel all those things? 2xh plus h squared all over h. Okay. What do you notice about your top numerator? Do you have anything in common? Stay with me. All right, stay with me. I'll give you time to copy this. All right, do you see anything in common? H. So what is it if you factor out an h? Stay with me. What is it if I take out an h? What do you have left over? 2x plus h all over h, isn't it? Okay, hold on. Stay with me. Do you notice anything? Do you think we did this correctly?
Yeah.
Yes. Remember we talked about this when everything cancels out nicely with limit, and now we can use direct substitution? It canceled out nicely. So go ahead and copy up to there. Okay, so now we have this limit. Remember, we started with this ugly, complicated thing. Remember that? We started with this very ugly thing. Now it is simplified to, what do we have? 2x plus h, and can I use direct substitution? What is it if I use direct substitution? 2x is your slope formula. 2x is your slope formula. What do I mean by slope formula? I can use this for any point, and it will give me the slope. So do you remember part A? What point, we're still on part A, what point am I supposed to use?
0, 1.
0, 1. So do you see this? I have a point, I need to find the slope, but I need to use this one. I need to use this for the slope. Okay, hold on a second. I've been really busy today. Hold on. Here we go. Sorry, my mistake. We're going to continue. All right, so here we go. Okay, so remember I was saying that this is our slope formula. We use this to find all the slope. But we don't have to because I'm too lazy to find all the slope. I just want to find the slope for the ones that they're asking for. So do you see this point? They're asking for 0 and 1. So remember, 0 is your x value, right? And 1 is your y value. And we need to plug in what number into this slope formula? 0. So this is 2 times 0, which means your slope is 0. But that kind of makes sense from the graph. Do you remember the graph on the top? Do you see this slope right here? Do you see this line? It looks like you have a slope of 0. Did you know that horizontal line is a slope of 0? If you didn't know, it is, okay? Alright, slope of 0, horizontal line. So it matches. We still need to find the equation of that line, right? Alright, we're not done yet. So how do I find the equation of the line when you have a slope of 0 and when you have a point of 0 and 1? Remember at the beginning of the class, I said we must use what formula? Y minus y1 is equal to m times x minus x1. Alright, so what do you think is, like, which one is x1 and y1? Do you know? Your order pair is your x1 and y1. Alright, so let's go ahead and plug it in. So if you plug this in, isn't this y minus, help me, 1 is equal to 0 times x minus 0. But what is 0 times anything? 0. So you have y is equal to 1. And that is your horizontal line at 1. Isn't that what we had?
Yeah.
Horizontal line at 1. So that makes sense. So we found part A. Check. We're done. Okay, now we still need to find part B. Right? But part B, do I want to go through this ugly steps all over again?
No.
Hell no, right? We don't want to do that. But now we have a slope formula. What is our slope formula? Yeah, remember our formula is 2x. Using which point? What's the point we're using? Negative 1 comma 2. So how do I find the slope? Here it is right there. This is it. Okay, I'm going to circle in red multiple times like this. Okay, so how do I find the slope for this point? So you plug in 2 times negative 1, so your slope is negative 2. Again, which formula do I use? This one on the top right here. So help me with this. Let's plug it in. So this is y minus 2 is equal to negative 2 times x plus 1. Alright, sometimes in your book, I'm not saying every time, sometimes they leave the answer like this, which is fine, but can we simplify this? Yeah, so go ahead and simplify this. Alright, isn't it negative 2x minus 2, and then you add 2 to the other side? So what is it if you add the 2 to the other side? Y is equal to negative 2x. If I graph this line, I should get this line right here. Does it look like we're going through the origin and it looks like you have a tangent line? Yes, it does. It does. Okay. So how many of you guys follow what I just did in finding the slope? Oh, is this half of the class? Okay. Alright, so go ahead and take out your graphing calculator. Do you have your graphing calculator?
Yeah.
You should have your own graphing calculator. Stop using mine. I mean, if you don't have one, it's okay. I'll let you use mine, but eventually you need to have your own. Right. Embarrassing? Well, you need it for the AP exam, so might as well get it. Oh, did you guys get the AP class code? Okay. If you don't have the AP class code, let me know. Okay, for AP class code, make sure you sign up for the right period. Okay, I gave you both, third and fourth. Do not sign up for fourth. Make sure you, only from this class should be third period. Alright, so go to y equal to. Do you remember our original function? It was x to the second power plus 1. And then, do you remember our the tangent line, first one, wasn't it y is equal to 1? And then do you remember our second tangent line, which is negative 2x? Alright, and then graph all of them. There's that tangent line. And there's the other tangent line, right there. You see that? Nice. 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 Okay. Can you see it okay? Alright, so there we go. So that's our goal for today. Now, our example was one of the easiest examples. Why? Because this function is very simple function. Guess what? We're going to have a rational function, which is a fractional function, which you need to simplify. We're going to have square root function, which you need to simplify, and all that stuff. So, let's go to your homework page. Oh, well, hold on. Before we go to homework page, everyone turn to 127. Page 127. Alright. On the top, okay, on the very top, you're going to find a definition on page 127. Do you see a definition of what? Definition of derivative. I want you to look at it. Doesn't it look very similar? What does it say? It says limit, change of x goes to 0, f of x plus change in x minus f of x all over change of x. Doesn't that look very similar to what we just did? Which definition? Remember I told you to change this because this is just too fancy, right? So remember the definition of tangent line? Tangent slope? What do we say? It is limit h goes to 0, f of x plus h minus f of x all over h. It's the same thing. So if they ask you to find the derivative, are we doing anything new? If they're asking you to find the tangent slope, are we doing anything different? No. Do you think this book will tell you to find a tangent slope and sometimes find the derivative? Yes. But it doesn't mean anything for now, okay? It's the same thing. Of course, you need to know the difference between derivative and tangent slope. You know, we'll get into like differentiation and all that stuff, but for now, I want you to think of it as same thing. All right? Now we go to our homework page. Go to page 131. Look at your Canvas. Part of your homework, everyone go to your Canvas. There are about 10 questions you need to answer for today. I didn't give you a lot. I can give you a lot more, believe me, I have. Okay, I mean, if you ask Mr. Cabrales, he'll tell you that I used to give out a lot more homework. Right? Yeah, 10 is not enough. But tomorrow, I'm going to give you only 6. I expect you to finish. You will struggle with some of the questions. Do you understand that? But you only have 10. I want you to struggle. Try to figure it out. Don't give up on it. Do your best. Look at examples. Look at videos. Whatever you need to do, figure it out. Alright, so let's take a look at some of the harder ones. Take a look at number 21. I think that's part of your homework. Either today or tomorrow. So we have f of x is equal to 1 over x minus 1. Read the direction. What do they want you to find?
Derivative.
Okay, derivative. Alright, so derivative. Do I need to change anything? No. What's our formula for derivative? Limit h goes to 0, f of x plus h minus f of x all over h. And look at how difficult this one gets. It's not difficult. It's difficult because we're not used to solving complex fractions. We just didn't practice. All right? So let's see. So this one is limit h goes to 0. Can someone tell me what first bracket of f of x plus h will be equal to? Think about it.
1 over.
It is bracket 1 over parentheses x plus h, close the parentheses. Stay with me. Stop copying. Stay with me, okay?
Plus h.
1 over parentheses x plus h minus 1. And close the bracket. Stay with me. Stop copying. Minus your second bracket. What is your second bracket? 1 over
X.
x minus 1. There it is. And everything over
H.
h. Alright, now you copy. That looks so ugly. It does. Right? Because we're not used to it. Can we use direct substitution? Of course not. For all of your questions, you cannot use direct substitution. Do you understand that? Because we will always have h as a denominator. So what do we need to do? You need to simplify this. How do we simplify this? We have a fraction and a fraction over h. So how do I simplify this? Anybody have an idea? We just took a test on this. You need to find a common denominator. Very good. You need to have a common denominator. So what do I multiply this first bracket by? X minus 1 on the top and x minus 1 on the bottom. What do I multiply this parenthesis bracket by? X plus h parentheses minus 1 and x plus h minus 1. Like that. Okay? Do not multiply the bottom one. Okay, so let's see what we have. This is limit. Stay with me. Do not copy this. It is, denominator is x minus 1 times x plus h minus 1, and close the parentheses again. Do you see it? Minus denominator x minus 1 times parentheses x plus h minus 1. Don't copy, just stay with me. What is it on the top here?
X minus 1.
X minus 1. What is it over here? X plus h minus 1. You see that? And you can put a parenthesis if you like. Okay, go ahead and copy this now. All over, I forgot, almost messed up. All over
H.
h. All right. Now, stay with me, okay? I'll give you time to copy more if you need it. All right, do you see this minus? You always need to distribute this negative. Don't forget to distribute your negative. Do you understand?
Yeah.
To all of them. So it is everything over x minus 1 times parentheses, x plus h minus 1. And then on the top, we have x minus 1 minus x minus h plus 1 all over h. Whew, it's still ugly. All right, so let's go ahead and copy that. I'm telling you, a lot of these questions are very demanding. Again, it's only demanding because we haven't practiced. All right? You should have learned all this, but we didn't get a chance to. Man, they should pay me double for teaching you integrated 3 stuff and this one. All right, do you notice anything from the top, on the very top? You notice anything? Cancels. X and x cancels out. What else? 1 and 1 cancels out. So we have a limit. H goes to 0. Stay with me again. Negative h all over x minus 1 times x plus h minus 1 all over h. All right, we just had something similar to this on your test. How do I simplify? Stay with me. I will let you copy. Stay with me. How do I simplify this fraction over h? What do we do? Remember, h is same thing as h over 1. So what do I do? Multiply by the reciprocal, which is 1 over h. It goes like that, right? Okay. Do you think we did it correctly?
Yes.
How do you know? Because h's will cancel. What do you have left over then? Limit h goes to, stay with me, negative 1 over x minus 1, x plus h minus 1. This is what we have left over. All right, so go ahead and copy up to there. So all of your questions are about finding the derivative. All of your questions are finding the tangent slope. Do you understand that? So tangent slope derivative, same thing. All of your questions, you need to go through this process. Can I use direct substitution now? Yes. What is it if I use direct substitution? Isn't it negative 1 over x minus 1 times x minus 1? X minus 1, what did you say? X minus 1 times x minus 1. And what is that? This is negative 1 over x minus 1 squared. This is your derivative, or it's called derivative, or what did I say? This is your tangent slope formula. Okay? This is your formula. I can use this formula to do what? I can use this formula to find what, guys? Slope. Slope of anywhere on your function. So in this particular problem, go back to number 21, do they give you any point?
No.
No. So we are done. But what if they give you points? What do you need to do? Plug in to find what?
Your m.
No, slope. You need to find the slope, and then you use a point to find the equation of the line. Does that make sense?
Yeah.
Okay. So that's it for your lesson. So I want you to try at least one problem before you go. You got about 6 minutes, okay? Go to your homework page. And what is your very first question? Number 7. Let's see if you can find the tangent slope at that point. Okay? And we are done.